Now we come to the key question of naming. As we now know, on the internet, messages are carried in packets that are addressed with numbers called IP addresses. So how do we determine those IP addresses? After all, it's infeasible for people to remember the IP address of each server that they want to communicate with. Are you really going to be able to remember that www.apple.com is 17.253.207.54? So instead, hosts are given easy to remember names like www.apple.com. These names are called host names. What we need then is a way to translate host names to IP addresses. Here's where the domain naming system, or DNS, comes into play. DNS translates host names to IP addresses. People often think of DNS like the phone book, but instead of translating names to phone numbers, it translates names to IP addresses. For example, www.apple.com translates to 17.253.207.54. Note also that host names live within domains. For example, www.apple.com is in the apple.com domain. The DNS system is split into two parts, recursive and authoritative. Recursive DNS is user-facing and authoritative DNS is domain owner-facing. We will now explain each of these two sides in more detail. Let's look first at recursive DNS and how it is configured. Your computer's operating system will be configured to use one or more recursive DNS servers that are usually provided by your ISP or your company's IT department. For example, opening up my computer's configuration panel, I can see that my computer is configured to use two recursive DNS servers at IP addresses 75.75.75.75 and 75.75.76.76. Those servers are run by my ISP, in this case, Comcast. Either of these recursive DNS servers can provide DNS lookups for all of the applications running on my computer. For example, any application on my computer can send a query for www.apple.com to either of those recursive DNS servers, and it will answer with the IP address 17.253.207.54. So how do the recursive DNS servers come up with the answers? After all, they can't possibly know the answer to every possible hostname lookup. That's where authoritative DNS comes in. So let's look now at authoritative DNS and how it's configured. And to do that, we have to start with domains. A domain, such as apple.com, has to be purchased from an organization called a registrar. There are many registrars out there, many of which you might have heard of or have done business with. Examples include Network Solutions and GoDaddy. Once you've purchased a domain from a registrar, you have to set up some authoritative DNS servers and provide the list of those servers to the registrar. In this example, Apple has 4 authoritative DNS servers for its domain, apple.com. To configure those authoritative DNS servers, you have to create and upload a zone file to them. Essentially, the zone file lists all of the translations for the host names in the domain. In this example, the zone file for apple.com includes translations for host names www.apple.com, mail.apple.com, vpn.apple.com, and whatever else is needed. Note that the authoritative DNS servers for the apple.com domain only need to be able to translate host names in that domain, and any of the domain's authoritative DNS servers can perform that function. In our example then, any of the 4 authoritative DNS servers for apple.com can translate www.apple.com into the IP address 17.253.207.54. The important point here is that the authoritative DNS servers for apple.com only need to be able to translate host names in the apple.com domain. They do not need to be able to translate host names in the google.com domain, for example. That responsibility would lie with the authoritative DNS servers for the google.com domain. This separation of responsibilities is what allows DNS to scale as it does. Now, let's look at the two halves of DNS work together. When an application on my computer wants to look up www.apple.com, it starts by sending the query to any of the recursive DNS servers that we saw configured in my computer's operating system. That recursive DNS server does not a priori know the answer. So to get the answer, it sends the query to any one of the authoritative DNS servers that we saw configured for the apple.com domain. The authoritative DNS server knows the answer. It's in the zone file, so it just has to look it up. It can then send that answer back to the recursive DNS server. Finally, the recursive DNS server sends the answer back to my computer. In doing so, the recursive DNS server will remember the answer for a configurable amount of time so that the next time it receives a query for that same host name, it can skip the step of going forward to the authoritative DNS. You might be wondering, how is it that the recursive DNS servers were able to find the authoritative DNS servers for the domain in question? The answer is hierarchy, which is facilitated by the registrar. Remember the registrar? The details of how the hierarchy works is beyond the scope of this presentation. The DNS is a critical and foundational component of the internet. When DNS is broken, you really can't even use the internet.